Okay, let's go on to the next problem. In this problem, well, first let's read the problem. A poll asked 1,006 adult Americans how much it would bother them to stay in a room on the 13th floor of a hotel. 131 of the respondents said that it would bother them. The main thing that we want to do in looking at this, the first thing we want to do is look at what kind of data are we looking at. And we can see that if they are answering the question, would it bother you to stay on the 13th floor of a hotel? The answer is a yes-no answer. So this is qualitative data. Okay. So what we're going to do when we analyze this is we're going to look for a population proportion. Okay, that's really what we're analyzing here, is a proportion of people that would be bothered by staying on the 13th floor of a hotel, as opposed to a mean that we would get with numeric data. Okay, so first let's find a confidence interval for the proportion of people that would be uneasy with the 13th floor. So what we're going to do is on our calculator, we're going to go to the stat menu, and then go to the tests, and we want the one proportion z interval. I believe it's under letter A. Okay, so let's look on our calculator. So stat, tests, go down to letter A. There's the one prop z int. X is the number of people that said yes or have the characteristic in our survey, and there's 131 of them. N is the sample size. How many people did we ask the question to? 1,006. And we were looking at a 90% confidence interval, so our C level is 0.9. So then we hit calculate, and we get this interval, 0.11277. to 0.14767. Okay, so that's our confidence interval. Now let's look at what that means. So let's interpret this confidence interval. So we can be 90% confident that the proportion of all, who did we survey? Americans? Yeah. So we're 90% confident that the proportion of all adult Americans that would be bothered by staying on the 13th is between 0.11277 and 0.14767. Another way to say that is that between 11.3% and 14.8% of all Americans. All right, so that's another way to phrase the ending part of that question in terms of percentages as opposed to proportions. Okay, find the margin of error and write the confidence interval as a point estimate plus or minus a margin of error. If I look in my book, I'm going to find a nice complicated formula for margin of error that some of you may have been using. But the idea behind the formula for margin of error is that's what we use to compute our confidence interval. If we already have a confidence interval, we don't need to go back and recompute that margin of error. What we can do is say, I know that my confidence interval goes from the middle by the margin of error in either direction. Okay, so if I think of this as a number line, here's my center value p hat that we got out of the problem. And in our calculator, it even tells us that when we did the confidence interval, that the p hat is 0.13. And if I go in either direction by the margin of error, then I'm going to get the values on my confidence interval. So we had 0.11277 and 0.14767. So if I want to find that margin of error, I can just take that upper value minus the middle value. And just do one simple subtraction rather than a longer, more involved computation. So on my calculator, I'm going to take 0.14767 minus 0.1302, and I get a margin of error of 0.01747. Okay, so I could write my confidence interval, and instead of writing it as an interval of values, I could say that the proportion, the population proportion, P equals 0.1302 plus or minus that margin of error. Or as percentages, 13.02% plus or minus 1.747%. Okay, so it's another way to look at a confidence interval. If I was looking at a confidence interval done in, say, a study in a magazine or something like that, the study wouldn't say, I have this interval of values that we could have for the population proportion. They would say, it just is 13%, and we would have a margin of error of 1.7%, and that's the type of way you might see that written. Okay, last part, let's do a hypothesis test. Test the claim that more than 10% of adult Americans would be bothered by staying on the 13th floor of a hotel. So here, I'm going to do a hypothesis test. I need a null hypothesis. I'm testing that more than 10%. So my null hypothesis is that P is 10%, or as a decimal 0.1. My alternate hypothesis, what I'm trying to figure out is it more than that? So is P greater than 0.1? Okay, so I'm going to go to Stat, Tests, and I believe that's number 5, the one prop Z test. Okay, so we'll pull up our calculator, Stat, Tests, there it is, number 5. And our null hypothesis is that we had 0.1. There's the x and the n from the confidence interval. And this time my alternate hypothesis is that it's greater than. So let's hit calculate. And we get a p-value